Hello, and thank you for this opportunity to present. So today I'm going to be talking about something that I've been passionate about for the past 30 years. I've been pursuing this in both academia and industry, and it's very much a part of what I do every day at Kitware, and that's open source software. So as you're building a new product, as you are upgrading a product or pursuing a new version of a product within a larger company or a small business or even within academia, you'll often hear the adage, don't reinvent the wheel, all right? Don't be one of these guys, all right? Don't think that you can do some mundane thing better than everyone else or spend your time doing that mundane thing. And instead, you want to focus on innovation. The challenge that we face is that in academia, as you're a student, we're often kind of rewarded for the opposite. Now, often there are group assignments in which you can collaborate with other people in order to come up with your solution. However, more than often than not, when taking an exam, when doing your homework and so forth, you're doing it on your own. All right. So you are officially doing the same thing as everyone else within that classroom and you're competing with them. All right. You're reinventing the wheel. And so wonderful in academia as a student, great way to learn. However, once you're out in industry or else a professor operating on your own, you really want to focus on the innovation. You want to focus on the stuff that not everyone else is doing. You want to be unique and stand out from the crowd and let them deal with the mundane. And that's done via open source software. And I'm not saying open source software and that in academia or industry, everything that you do should be made open source or freely available. Not at all. There's definitely a place for copyright, patents, intellectual property, and so forth, proprietary information. Very much a big fan of it. It's necessary in order to really secure a company so that it remains viable during its initial startup period. However, it's really just a component of what needs to be done. It's that layer on top that we're talking about is the proprietary work. What you want is that stuff underneath, the mundane. You want to build upon open source for that. And so the way I think about this, continuing that analogy, is we're dealing with the double stuffed Oreo. All right, the double stuffing, the good stuff inside, that's open source software. But it's built on top of often your proprietary hardware. So these are your cloud resources, or your special GPU, or your special endoscope, or whatever hardware it is that you've developed. All right, that remains proprietary. That's yours. That's the device you sell. But then the software that's running with that device, that should be open source software in the majority of it. All right. But then on top of that open source software is that thin layer, that proprietary information that you've developed. That is that custom software that you've developed that makes your product unique. And that's really where you should be focusing your effort. And that is the story, that is the strength of open source software, building this cookie together that you can take a bite out of. So keys to success in industry and in academia when starting a product or, again, improving an existing product, it's reducing costs and reducing risk during your research and development phases. But then it's also recognizing that the majority of the costs associated with software is not in that development of that software, but it's in the maintenance of that software. All right, it's fixing bugs, it's doing minor upgrades, it's adapting it to new versions of operating systems or device drivers when they come out. It's maintaining compatibility with other systems. That ends up being the vast majority of the cost associated with a piece of software. It's not that initial development. So that might be what you're fearing as you do your new startup. Am I ever going to get the software done? But really, it's that software maintenance where the burden really begins. And then there's this notion that you have to stay innovative. There's the truth that you have to stay innovative. All right. You always have to be looking at what the competition is doing, looking at what researchers are doing, what is the latest and greatest algorithm out there, evaluating it and integrating it into your product, and then going after that new FDA approval for that increased improved release. That's a very costly process, typically, with a lot of risk associated with it, and it can burn up a lot of time if not done effectively. And what I argue is that by using and contributing to open source software, you're going to reduce the risks and reduce the costs associated with research and development. You're going to reduce maintenance costs, and you're going to promote innovation. All right, reducing costs and risks associated with research and development, this is not reinventing the wheel. This is the one that hopefully all of you all accept. I mean, if you look at these open source platforms that exist out there, ITK, PyTorch, Monai, these open source platforms, They cost millions of dollars to develop these platforms. There are thousands, tens of thousands of person hours contributing to these software. And these softwares were really made by often contributions from the best and brightest in the field. So when you're using that software, you're standing on the shoulders of giants, all right? And so that's definitely a cost reduction effort, because you can just plug these pieces together to make your system work for that mundane components. But also it reduces your risk, because most open source software has already been integrated into other products that are out there, all right? And so it is something that is thoroughly tested. It used to be that old open source was kind of the Wild West. You didn't know what to trust and what not to trust, but really you can trust open source, the majority of open source today. Look at how many developers are contributing, where has it been used before, and use that to select what open source you build upon. But I think you'll find that there's some outstanding samples that are out there. And then also within the medical field, you have to go for FDA approval. And you can either develop all of your software yourself under whatever guidelines and whatever quality management system that you define, or you can treat a large library as software of unknown pedigree, of soup, and integrate that large library into your toolkit, into your product, without having to go through all the FDA approval process for every component and line of code within that soup. And so that open source software, it becomes soup. It becomes software of unknown pedigree that you can integrate and then just test against, saving you, again, a lot of time and risk. And then maintenance costs, this is where it really shines, actually. When a new version of an operating system comes out, you aren't the one who necessarily has to update, ITK to work with that new operating system, or PyTorch to work with the new version of Python. Other people are going to do that for you. So a lot of that maintenance of your software, if you stay up to date, if you use this open source software and you contribute your bug fixes back to it and so forth, so it stays in sync, you'll end up having this wonderful resource that's the entire open source community contributing back to your product throughout time. And so it's really somewhere where that massive cost associated with maintenance can be reduced and the burden reduced greatly. And then lastly is the innovation component. Again, you're standing on the shoulders of giants, and there's always new giants adding new methods into these toolkits. But when considering whether or not to release a new version of your product, or whether or not this new algorithm that's been published in a journal or in academia, you have to question, does that algorithm really work as well as the publication says, all right? Because it's not always quite honest, all right? And it's not that they're dishonest, but it's not necessarily a complete and thorough evaluation. Well, if that software, if that algorithm has also been released as open source software within this toolkit that you're using, you'll get to compare your method against that method using your data very quickly. All right, so as new algorithms are being added to these open source toolkits, you can always compare against them until a new algorithm works better on your data than your existing algorithm. And then you know with confidence that you should use that algorithm moving forward, and maybe it's time for another FDA submission for a revision to your application. And so it's a wonderful way of integrating innovation by others into your tool. And it allows you to focus on innovation. You don't have to do the mundane. You don't have to keep reinventing the wheel, all right? You can focus on what makes your product unique and special and different. And that's really the strengths that come with open source software. So hopefully you've enjoyed this talk, got some ideas from it, and as you go pursue your projects, you're going to look at open source software as opposed to doing the not invented here, trying to do everything yourself, but really look to stand on the shoulders of giants. There's great resources out there to help you use open source software, wonderful question and answers and forums and so forth. And please seriously take a look at it, and you will reduce the costs and risks associated with your product now as you do the development and well into the future. Thank you very much for your time.